Okay, in this question we're asked to sketch the complete graph K5, okay? So I have it done here. So K5 means that there's 5 vertices, and we have them there, 1, 2, 3, 4, and 5. And there we are, 1, 2, 3, 4, and 5. And the idea of a complete graph is that each vertex is connected to each of the other vertices. Okay, so 1 is connected to 2 by that edge, 3 by that edge, 4 by that edge, and 5 by that edge. And similarly, 2 is we already shown that it's connected already by that using one of those edges there. It's connected to that edge, 5 by that edge, 4 by that edge, and 3 by that edge. So each pair of vertices has an edge connecting it. Okay? So that's the idea of a complete graph. So necessarily there are 5 vertices. So for each vertex there are 4 other vertices that it has to connect to. Okay? So that means that the degree sequence, the degree for each vertex has to be 4. For a K5 graph, the degree has to be 4. The degree sequence is 4, 4, 4, 4, 4, basically. Okay? Now, how many edges does this graph have? So we'll just have to count them out. So what we'll do here is just go along the perimeter and just count those ones out. Just do a sort of two-stage process. 1, 2, 3, 4, 5. Okay, and do the internal ones here. 1, 2, 3, and 4. Okay. Sorry, there's 5 external ones and 5 internal ones. I think I might have misspoke when I was actually counting them out. But essentially 5 and 5. Okay? So that means that there's 10 altogether. Now, just as a remark, so there we have it there. So let's just go back to normal. So we have 5 vertices. Okay? And each of those vertices has degree 4. Okay? Now, the thing is, we are going to be double counting some of them. So, for example, if we're counting this as 1, that means that we can't count it a second time. So, essentially, each vertex is getting counted twice. So, for 1, this edge here, this red edge, is getting counted for 1, and it's also going to be counted for 2. So, essentially, what we have to do is stop a double count, which is divided by 2. So altogether we have 10 there. That's just a sort of way of figuring it out. Now in this case, n is the number of vertices, actually, which I should say as v, and d here is the degree sequence for each of the vertices, and that is n minus 1. So 5 times 4 divided by 2. Okay. Now, so the question here is, what is the degree for each vertex of the complete graph Kn? Well, actually, so it has n minus 1. So if there's n vertices, that means for each vertex there's n minus 1 other vertices, and it has to have an edge connecting each of them. Okay? So the degree is n minus 1. Okay? And what does that mean for the number of edges? Well, it means it's n times n minus 1 over 2. Now, this is specific to complete graphs. Okay? This expression here. And it's handy to know this. Okay? So that's it there. We leave it there. So that's just a quick exercise on complete graphs.